Hi, Jeff DeMore here, Converter Accessory Corporation. Today I'm going to be speaking with you about one of CAC's simpler methods of holding a core on an unwind or a rewind. We're going to be talking about CAC's core cones today. This is CAC's core cones. It's a set of core cones. These are 3-inch. The core cones are available in 3-inch and 6-inch. I have two different types here. One has an option for a split bushing and one doesn't. I'm going to show you the difference. So this core cone has a split bushing built into it. So you'll see there's a through bore. This will mount onto a through shaft, which looks like this. I'm going to show you how it mounts onto the through shaft. And the way this one is designed, we counterbore the end and we mount a bushing in here so that when you tighten up this set screw, you'll see that bushing will close down. And that's what will clamp onto the through shaft that I just showed you. So you can see how that closes down. This is a core cone that does not have the split bushing in it. The split bushing is an option. It's a few dollars adder, but it's just a slightly additional money, but it can save you a lot of time in the end. This one has 2 set screws that'll lock directly onto the through shaft. So you can see the through bore. Again, that through shaft, this is going to slide onto the through shaft, and those set screws will contact the through shaft directly. So as I tighten these up, you'll see the screw come down, and that would contact the shaft directly. The advantage to the split bushing design is, the biggest advantage is that those set screws never contact the through shaft, so you don't mar up the through shaft. When you use core cones without the split bushing, over time, from tightening and loosening the set screws, because every time you want to take the core on and off, you have to take one of the cones off, you can mar up or burr up the through shaft. With the split bushing, that never happens, so it can save your through shaft over time. So this is, I wanted to also talk to you quickly about CAC's lightweight through shaft. This is CAC's lightweight through shaft. This one is designed for our little test stand. This is built for a 25-inch wide material. Of course, you can run narrower, but up to 25 inches. This shaft with the core cones only weighs 12 pounds. It is 1 3/4 inch OD, so we get a lot of beam strength out of this, so we can handle very heavy rolls, but it's very lightweight, very easy for operators to handle. The way we get the lightweight design is we manufacture the through shaft from hollow steel tubing. This is a cutaway view, so you can see inside that this is all hollow. The outside diameter of the shaft is 1 3/4, and then we would design the wall thickness to give you the maximum beam strength for your application, depending on your roll weight. We counterbore the ends of the hollow steel tubing. We mount solid steel ends into there. They can be round. These happen to be square to fit our safety chucks. And then we weld the ends into the hollow steel shaft. So it looks solid from the outside, but it's very lightweight, very easy to handle. Again, with the core cones mounted, that shaft is only 12 pounds. So I'm going to take the core cone that does not have the split bushing. I marked the shaft earlier where I want the core cone to line up, but this slides right onto the center shaft, and then you take your set screws, you tighten them down. So those set screws right now are digging into the shaft, and that core cone is set in place. Then we take, this is going to be used, I'm going to be showing this on a rewind, but it's the same application for an unwind. We're going to take an empty core, slide it onto the shaft and the core cone assembly. Then I'm going to take my core cone that has the split bushing built into it, slide that on, and push it in so it grabs the ends of the core and tighten up the set screw. Now in this, the one with the split bushing, that set screw never contacts the shaft. Instead, that split bushing is going to close onto the through shaft. So now that core cone is locked in place, and the core of this whole assembly is one assembly. We're going to take this, mount this into our rewind stand, into our safety chucks. We're going to take our web, and close the safety chucks. The safety chucks, I have a separate video showing the safety chucks, and we have other videos showing the components in this machine. Today we're just talking about the core cones. And start up the rewind, and that's how you use core cones in a rewind application. So when you want to go to make a roll change, you shut off the unwind or the rewind, open up the safety chuck, pull the shaft out, pull the shaft out. Now I'm going to pull off the end that has the core cones without the split bushing. I'm going to show you the shaft. So to take the roll off, loosen up the set screws. And then you'll see on the end of the shaft, that's where the core cones dug into the shaft. Or I'm sorry, the set screws dug into the shaft. So without the split bushing, when you pull this one off, you'll see, I'm sorry, with the split bushing, you'll see that there's no marks where the set screws were. The other one excellent application for core cones is where you have cores with crushed, applications where you have crushed cores. Sometimes when you have rewound rolls of material, sometimes this core will get crushed down because of inwound tension. And we've probably all seen crushed cores. Core cones are an excellent way of holding a crushed core. They don't fix the crushed core, but they allow you to run a roll of material that has crushed cores where you can't get an air shaft or an air chuck into the crushed core. Core cones are an excellent option for that. I appreciate your time. Thank you for watching the video.